Welcome back to another video of Business Analytics Complete course. In the previous video, we talked about correlation topic, and today we have the same title, more important, more practical. Today we are going to talk about regression concept. We are going to learn how we could predict amount of cells by the regression formula and in Excel software. So, if you are a new member and would like to support me, don't forget to click on subscribe button and get ready to join us. Let's get started. Okay, let's continue on the screen. Regression and correlation are closely related, and regression is analyzing two or more variables. But what is the difference between regression and correlation? In correlation, the two variables, x and y, are treated as equals, but in regression, one variable, which is normally x, is called the independent variable, and other one is dependent variable or outcome variable. Okay? Regression gives you an equation to estimate the dependent variable, whereas correlation just gives you an idea about the association or the strength of relationship. So we can say regression helps to predict the future. Now let's see formula. A regression equation is used in stats to find out what relationship, if any, exists between set of data. For example, if you measure a child's height every year, you might find that they grow about 3 inches a year. That trend, growing 3 inches a year, can be modeled with a regression equation. Let me explain by another example. In this example, we want to predict the number of burgers sold. Here, we have a data table with two columns, mall visitors amount and burgers sold number. We are asked to predict sales amount for 30 days later. First, you need to establish a relationship between the burgers sold and more visitors. If you plot the scatterplot of these two variables, so number of visitors is on your x-axis and the y-axis is sold amount. So here we have a clear relationship. About a scatterplot and other type of charts, we talked about in previous video, and I will mention that video above this video. Okay, now assume that you have got this equation. Y is equal 2.28 into x plus 41.1. X means visitors, right? Number of expected visitors next 30 days is 5,000. How many burgers will be sold? So we should replace 5,000 in this formula. What we have? 1,131 or 1131. Okay? This is the amount of sales that we predict for 5,000 visitors. Let's check again formula. The equation has the form y equal a plus bx, where y is the dependent variable. That's the variable that goes on the y-axis. X is the independent variable. It is plotted on the x-axis. B is the slope of the line and is the y-intercept. A slope, or the efficient point to 1 year in the number of visitors, is already given here. But what does slope mean that are efficient? It simply means that for 1 unit change in X, how much does Y increase? So in this example, if there are 100 people visiting the mall, there will be 21.8 people eating burger, right? Now let's do a quick exercise of how to get this regression equation. Let's first of all make a scatterplot chart for this data. So select data, and we have a scatterplot chart, and now we need to draw a trend. So here, apply trend line, and from this section you should click on display R square value, and we have also another option here, display equation on a chart. So now we have our formula. We'll learn how to create a regression equation using a scatter plot. Dependent variable, I mean Y variable, and independent variable, that is X variable. In simple words, we are using X to predict Y, right? So we have predict value and actual value, and the difference between these two data called error. So we have another concept here. First, look at this chart. We said what is error, and it was difference between actual and predicted amounts. So now in this case, if you attention predict is so close to actual, the best fit line is our new concept, and it means minimizes the error. So best fit line is a line which best predicts the data. We can say if 100% of Y is explained by X, then that is the best regression equation, but in reality it's not the case. For example, height and weight. It's not that. As you know, height can't be 100% predicted, and there are other factors. As example, total variance. But about regression assumptions. Regression assumptions. Regression should not be used for prediction when the following assumption fail. Number one, the relationship between X and Y is linear. Number two, there should be no outliers. And three, variance of Y at every value of X is the same. And number four, Y is normally distributed at every value of X. One regression is used if the above assumption fail, then it's reflected in a lower R square. As a final point for this title, there are many other things that we can talk about to expand your notice and share more details, but I think this is enough for today, and we learn what we need. So hypothesis testing is our next lesson, and I will come back to you with this title. Okay, thank you for your attention. See you soon.